So we have this question of the homogeneous format. If you rearrange it, you'll understand that one is the function in terms of xy f, and this is another function in terms of xy g. So clearly it's of the homogeneous form. So we'll use our these two steps in order to solve it. So substituting dy by dx as v plus x dv by dx, x as it is instead of y, vx. So simplifying algebraically, x we can take out common from numerator and denominator gets cancelled, and we shifted on the other side minus v, taking the LCM minus v and v square. So this becomes dv into 1 plus v upon, this thing gets simplified as 1 minus 3v minus v square is equals to dx by x. For the right hand side, we'll integrate it, right? It will become ln x plus c. We can convert c into ln form. If we get the left side also in the ln format, log format, then constant also will substitute in the constant in the log format, because this is a general solution. Until and unless the values of x and y are given, it's a general solution. So there can be a multiple general solutions depending upon how you write c. And the left side of the equation, if we take, it would be taking out minus common, so minus 1 plus v dv by v square plus 3v minus 1. Separating it out, right? So to convert this in the integral format, we know that differentiation of v square will be 2v and differentiation of 3v will be 3. So numerator must be arranged in this format. To arrange numerator in this format, that is to make this term as integratable, right? So I'll multiply and divide by half. So it becomes 2v, and then further I want 3. So I'll add 3 and minus 3, v square plus 3v minus 1, half into 2v plus 3 by v square plus 3v minus 1, and minus half of minus 3 by v square plus 3v minus 1. So this thing, writing down as it is, this will, if we integrate, it will become ln v square plus 3v minus 1, and this thing if we simplify, it will become minus 3 by 2 v square plus 3v minus 1. These two terms are same, minus minus becomes plus, are same, so we can add them up. 1 upon v square plus 3v minus 1 common, and remaining part will be minus plus 1 plus 3 by 2 half ln v square plus 3v minus 1. So this thing will be 2 ones are 2, minus 2 plus 3 will be plus 1 by 2, so plus half of 1 upon v square plus 3v minus 1 minus half of, we can substitute the values of v over here, or in the later steps we can do it. I'll do it in the later step. This thing, to factorize this once again, to make it integratable, right here I have done the integration. To make it integratable, right, again we'll have to convert it into the some perfect square format. So we'll add the last term, that is the formula to calculate is middle term square, 4 into first term, middle term square, and 4 into first term, so last term would be 9 by 4. So we will add and subtract 9 by 4 in the denominator and numerator, in the denominator add and subtract. So it will get converted into the perfect square format, minus square root of 13 by 2 whole square. This part remains as it is, half ln half ln. So this thing in the format of x square minus a square, right? So integration of x square minus a square will be 1 upon 2a ln x minus a upon x plus a. So let's use this formula. So this integration will be solved as half was there already. Then 1 upon 2a, a is square root of 13 by 2 ln x minus a. So v plus 3 by 2 plus 13 by 2 and x minus a and x plus a. So v plus 3 by 2 plus root 13 by 2. These two gets cancelled. So it becomes 1 by 2 root 13 ln. Now we'll substitute instead of v x upon y upon x. So this would be y upon x plus 3 by 2 minus square root of 13 by 2, and here it would be y by x plus 3 by 2 plus square root of 13 by 2 ln format. And the other side, this minus half ln, it's as it is. So for this minus half ln also, I'll substitute the values. It was v, so v is y by x square plus 3y by x minus 1. Let us simplify this part. 1 by 2 root 13 ln, it would be 2y plus 3x minus square root of 13x. X we can take out common over here, so it will be 3 minus root 13x, and denominator would be 2y plus 3 plus root 13x minus half of ln y square plus 3xy minus x square upon x square. Now we'll combine left and right hand side. So left hand side of the equation is 1 upon 2 root 13 ln 2y x and 2y plus 3 plus root 13x, then minus half of ln y square plus 3xy minus x square, and this denominator x square I will separate it out, so it will become minus half of, it will become ln x square minus ln x square. This part is in the bracket. So minus half will have to multiply, and right hand side was ln x. As I said, C also will write it in terms of ln, right? So further writing down, minus half will multiply inside. Here it will become plus half. All other terms as it is. This thing we can remove the power 2. 2 will go to the multiplication. It will become ln x plus ln c. Ln x gets cancelled from both the sides. No need to combine. We can just keep it as it is, or any other format. Since log are there, you can combine them for sure, but the complexity of the equation will be much higher, so better we'll leave it here, and in case if you require some special solution, you can solve it further. Otherwise, this is the answer for the given differential equation. The concept of integration, right, are completely used in this, right? So we have this question, and then we have followed the steps to solve it. So we have this another question. Again, inspecting it clearly, we can rearrange it in the dy by dx will be equal to xy upon x square plus y square. So clearly you can see two different functions in the format of xy. So belongs to the homogeneous category. We'll use this step number 1 and step number 2 to solve this equation. We can take out x square common from the numerator and denominator gets cancelled. Rearranging it, this plus v and minus v can get cancelled, so no need to write, is equals to dx by x, right? This thing we can easily integrate, and we'll also add constant either you can add in log terms or as it is. So to simplify this one, minus 1 upon v cube minus v square by v cube. So minus 1 upon v cube dv its integration and minus 1 upon v dv its integration. We can see the log term appears. So we'll convert this one also in the format of log. So integration of this would be minus 1 upon 2v square, and this would be minus ln v is equals to ln xc. So this thing gets cancelled, minus minus plus, and v will be equal to y square by x square minus ln y by x is equals to ln xc. X square by 2y square ln xc plus ln y by x. So x square 2y square would be equal to ln xc multiplied by y by x. X gets cancelled. So ln cy is equals to x square by 2y square. You can further convert it if you want in exponential format. Cy will be equal to e to the power x square by 2y square. So you can keep this one as a final answer for the solution of this differential equation. Alternative answer for this question can also be modified somewhere like this. If you solve this, 2 you can shift on the other side. So 2 ln cy, this becomes x square y square is equals to ln c square y square, and then again converting into exponential format, c square y square will be equal to e to the power x square by y square. So depending upon where you drop up or how you rearrange, there can be multiple answers possible when the complexity of the question is higher. That is, if it is in the homogeneous form, for sure multiple answers are possible. So here we have another equation. If you rearrange, for sure it will appear in the form of homogeneous function plus y whole divided by x, right? So once again, a complex function of x, denominator we don't have any complex function, but still if one of them is a function comprising of x and y, both the variables, then it is of the homogeneous form. So once again, say substitution, step 1 and step 2, y is equals to vx from the numerator x we can take out common, so it will be root of 1 plus v square plus v by x. Rearranging dy by dx can be substituted as v plus x dv by dx. So x dv by dx will be equal to square root of 1 plus v square plus v minus v. This gets cancelled. So dv by, right, integrating on both the sides. So this integration would be ln, the integration would be ln x plus square root of x square plus a square by a, and this would be ln x, we'll use ln c. So I'll cancel ln from both the sides, combining this, so it will become xc, and this side would be y by x plus 1 upon y square by x square. This would be y by x plus square root of x square plus y square by x is equals to xc. Y plus square root of x square plus y square will be equal to x cube c. So this is the solution of this differential equation. So here we have one more differential equation. Now here for sure it is of the homogeneous format, but if you inspect, you have x upon y rather than common in all the cases we have y upon x. Here you have x upon y, so we'll modify our substitution a bit. We'll use x is equals to vy, and then differentiating with respect to y, we'll have dx by dy. V as it is, differentiation of the y will be 1, and then dv by dy. So this is the modification required for such type of the questions in which you have x upon y format. So let's do this substitution first. So dx by dy would be to the power v. I'll take out minus common from the numerator, so v minus 1. So this thing we can open up the bracket, ev dot v minus e to the power v, 1 plus ev, 1 plus ev, and dx by dy we need to substitute, it will be v plus y dv by dy. So take out minus, take minus v on the other side, y dv by dy will be ev dot v minus v minus v minus v dot e to the power v. So here this part and this part gets cancelled, would be minus 2v by 1 plus e to the power. So rearranging it, okay, here if this multiplication is ev, so this will be minus ev minus v, and y dv by dy minus common ev plus v upon 1 plus ev. Rearranging it, minus dy by y, integrating on both the sides, right? So here we'll use assumption that equal to t. So e to the power v as it is, differentiation dv will be equal to dt. So this will get converted as ln e to the power v plus v is equals to minus ln y, right, plus ln c. You can also even take minus ln c if you want. So e to the power x upon y plus x upon y, this would be minus c by y, this will be. So if you y dot e to the power xy plus x is equals to c. So this is the solution of this differential equation.